Now, solve. Doesn't matter what unit we're in. Doesn't matter what lesson we're learning. If it says solve, I want variable equals answer boxed or circled and said it's extraneous and no solution, right? That's what I want, ultimately. When it says solve, it doesn't matter what unit we're in. We can always check solving two ways. We can check it y1, y2 with our calculator, moving the equation to either side as much as you want to, right? If you get it set equal to 0, you're finding the x-intercepts. If you have it equal to two different things, you're finding the intersection point, the x. Or you could take it and literally just plug it back into the original and see if left side equals right side algebraically checking, right? There's no way when you walk away from a solving, you shouldn't know if you did it right or not. You know, happy or correct. These are the only two options I always say with solving. You should know if you got it right or not. So we did ones where we could do common base, right? So we had like 3 equals 9 to the x. You are not getting one of these on your test, like this exact question. It will be harder. But we did common base, so we said, hey, we can make these both be base 3. This would be 3 to the 1, that'd be to the 2x, and I'd go 1 equals 2x, and I divide by 2, and I'd have x equals a half. And then I plug it in here, and I go 9 to the half is the same as the square root of 9, which is 3, so I know I'm right. Right? Then Peter screams, log base 10 both sides. And I said, yeah, yes, Peter. Yes, we can do that. So we could do it with this one as well. We could go log of 3. I can write the base 10 or not write the base 10. That's the only one I don't have to write the base for. It's the same as like when you do the square root, right? When the index is 2, you don't have to write it, but if it's 3, 4, 5, 6, you do. The square root is the square root. This is log base 10, so I can either write the base or not. And then this one here is log base 10 of 9 to the x. Now the reason why I write log base 10 is to try and stop you from taking this 3 and putting it in the base and the 9 and putting it in the base. So if I do write the base 10, it causes you to not try and slide that number down into the base. And you will do it eventually. So I just put the base 10. Then we said using power rule, we could take our x, we could drop it in front, and we get log base 10 of 3 equals x log base 10 of 9. And then we divide by log base 10 of 9. Now look at this. This is going to equal a half, obviously. But I just want to show you something. So on your formula sheet over here, you have log formulas. This is the log and exponential formula, like it's relations of functions, but it's logs, and then growth and decay formula you're actually given. It's the only one. And then general form transformed with hip terms and columns, Scott. So the only log stuff we have is these 4, right? And if you look here, it says log BC, log base B of C. I'm just going to write it here so we can see it. Log base B of C equals log base A of C over log base A of B. We agree? That's the formula on the formula sheet. So basically what you can say is, if your bases are the same, so this is base 10 and base 10, which ours currently is. We agree? I could write that out as what? Yeah, log base 9 of 3 because of this rule. The base drops in, or the bottom one drops into the base. So I could write this as log base 9 of 3. Now, if you have anything above a TI, if you have anything above a TI-83 or any of the ones where like the exponent actually pops up, you have a button that you can type it in like this. So I'm going to show you how to do that. If you have the TI-83s, you have to divide them separately every single time. So if you have the TI-84s or anything where the exponent pops up, you just go math and then arrow up, and then there's a log base button, an A. And then you just put the 9 and the 3 in, and it gives you an answer of a half. If you have the old calculators, you have to literally rewrite this without the base 10, because base 10 we don't have to write, right? So you would actually have to put it into your calculator as log base 3, or sorry, log of 3 divided by log of 9, without the base 10, because you don't need the base 10. You would have to put it in like this, how it's written, like that. That's the only way you can type it into your calculator. So if you have a TI-83, which I think might only be Peter? Does everyone else have?
TIE.
Ah, you're not alone, Peter. But it doesn't do it. Yours is the fake plus. Yeah. This is a fake plus as well. And my pink one is a fake plus. They say they're TIE4 pluses, but they follow everything that TIE3 does. So if it's one that the exponent doesn't actually pop up in, or you don't have the fraction button, it's a fake TI-84 plus. It's like a TI-83, and they just put a new case on top of it. I have 3 of these. It's just set. There's an in-between state. I have like 3 of them that are like that, because I've been teaching for a long time, and therefore I got them in that state. But you just have to go log 3 divided by log 9. It's the same thing, right? It's not going to make your life that more difficult. And you get x equals a half. Okay, let's try this. I don't even know what went on, but I don't want to know. B. So what if we get something where you can't make it a common base? Well, we talked about that. That was all those word problems, right? Where we had final equals initial, then rate to the t over p, or whatever it was. It was divided our initial over, and then we just log base 10 both sides. But it was pretty easy. No, it was not evil. It was the opposite of evil. It was pretty easy because we just had an exponent that was like an x or an x over 10 at the worst case, right? What happens if we get worse than that? So let's try another one that's a little bit more difficult. So we do, let's go 9 to the x plus 1 equals 3, 4. I don't want it to be a nice common base. 4. Can I make it common base? No. And it's a little harder than the previous one because I don't just have an exponent. My exponent is actually x plus 1. My exponent is a binomial. Okay? Making it a little more difficult. We're going to have to use more of those log laws. So what do we do when we can't make common base? Log base 10 both sides, right? So we're going to go log base 10. And I write the base because I'm not kidding you. You're like, I would never write that 9 in the base, but you will. You're like, no, I wouldn't. You will. I've done it in 16 years. I can tell you, you will drop that 9 down there. It's the saddest day. So I start off with log base 10 at the very least to get the 9 to be the same height as the log. You can drop it off after. I don't really care. But it gets people to not put that 9 in the base because it can't be in the base. You're log base 10ing both sides. That's what we're saying, right? So log base 10 both sides, you can either write the base or you don't have to. Just do not put that 9 in the base. And then we have an x plus 1 up here equals log base 10 of 4. What is the ultimate goal? Why do we actually log base 10 both sides? Yeah.
To isolate for x.
To isolate for x. To get that x that's in the exponent that I don't know how to solve up there, to get it to come down in front so I can do it with like some real math from junior high and high school, like previous to this, right? So ultimately the reason why you log base 10 is to get that exponent to come in front so it's no longer an exponent and you can actually just do math with it. Not that you can do math with an exponent, but what are you going to do, guess and check? Like that's all you can do. So we drop it in front. When it is a binomial, I would hazard you to drop it in front as in brackets so that you realize you need to distribute it into the log. So I'm going to take this x plus 1, I'm going to drop it in front. So I'm going to get x plus 1 in brackets times log 9. You can drop the base off now if you promise me you will not put that 9 down there. Okay? And then this would be log 4. Always put your log in brackets. Now, the reason why I said to put the x plus 1 in brackets is to realize that you have to distribute it to the log. So you're going to get x log 9. And then 1 times log 9 is plus 1. You don't have to write the 1. I'm proving a point. Log 9 equals log of 4.
Did you just divide log 9 to the other side? X plus 1.
You can, in this particular case. They're not going to stay like this. So if we could just follow this step every single time when they get way more complex, you'll be fine. But yes, sure. Okay, what are we going to do next? In my steps, what are we going to do next? Move the thing that doesn't have a log to the other side, right? Just like if you had like 3x plus 7 equals 8, you'd move the 7, we're moving the log.
No, it's good. I can't figure out. Yes.
You can't divide it over. You can only because this one has an x plus 1. Normally, this one's nice. This one we convert to a log. We're just not doing that right now. Normally, we're going to log base 10. We have like x plus 1 and then 2x minus 4 over here. And then you're going to distribute them both. And then you're going to get x's on both sides. And then you just can't divide it over. To be honest, when you have one exponent, you're going to convert it to a log using log conversion. But you can always log base 10. So I'm just showing the log base 10 first. Because we're going to get to the hard ones in a second. So then we have x log 9 equals log base 4, not base 4, oops, log 4 minus log 9. And now what do I do? Divide by log 9. Now, if you're putting this in your calculator all at once, use the fraction button. If you do not have the fraction button, what must you do in order to force BEDMAS rules correctly? Brackets where?
Around the, like, the numerator.
Yes, around the numerator. You could put them around the denominator, it'd be excessive, but I guess you could. But it has to be around the numerator because you want the numerator, you want that subtraction to be done before you divide by log 9. So remember, your calculator will always do BEDMAS, so if you want something to happen, you have to put it in brackets. Or you use the fraction button. Now, you don't need that log button this time because it's base 10, so you can just use the real log button. So we go log 4 minus log 9 divided by log 9. And you're going to get negative 0.36, whatever. If they wanted an exact values, we'd have to go through it in a different way, which we're not doing today. So we're just going to do this for today. Negative 0.37. How can we check it? Go to the original, type in y1, y2, go. Remember, if you have the calculator, the exponent doesn't pop up, you have to put this in brackets. So, Nathan asked a good question and proved a good point. What you can do is he asked, can I just write this as log base 4 over, and I'm actually impressed with this because everyone forgets that everyone remembers that you can put common bases together, right? If you have a common base and a common base, you can write the numerators, both numerators over one denominator. We agree? That's the point of common base. But what everyone forgets is that you can actually separate two numerators that's over one denominator into two actual fractions, right? You can pull them back apart instead of putting them together. So he had said, can I go log 4 over log 9? And then write my other one over log 9 as well. Like just go back and re-separate them instead of having common base. So whenever you have a binomial numerator over a monomial denominator, you can always separate them out. And this is a good reason to separate it out because these are actually just ones. And we can rewrite log 4 over log 9 as log base 9 of 4 minus 1. And now it's more in a transformed form, right? But the problem with logs and exponentials, like I said, is not logs and exponentials. It's realizing that, oh, my answer is like this, and it's perfect, and it's correct, and it's right, and then they get that. Yeah.
So like you could also write it as log base 9 of 4 over 9.
Yes.
Is there any way you should do it?
Nope. If it's written response, this would be good, and so would that be good if they say exact values. If it's multiple choice, you just have to match what they have. And honestly, if it's all numbers, which it probably wouldn't be, you could work yours down to a decimal and work all the multiple choice answers down to a decimal. So the chance of this being a multiple choice, pretty chance of that happening, 0, unless we're looking for a technology outcome. Because you could just turn your answers all the decimals and type in y1, y2 and match. So often I would suspect this to be a numeric response where they could go in the form log base 9 of a minus b, what's a and b, like they could ask it that way, right? And then they'd have to do it in this format. So yeah, that's the hardest part, is trying to match their format. And sometimes it's not hard because you think the same way as that person who's writing the question. All right, what happens if I make it harder?
Everything falls.
No.
It gets harder.
It gets harder. That's all that happens. Okay, so what if I do this? What am I on? 3? So I'm going to go, is it C? 3 and C rhyme, okay? So does D and B, but I don't care, okay? And C, that's all I'm drawing you there. And D. And D, okay, there's lots, but not Z, exactly. Or, but if they say Z.
That's cursed. That was the point. Z is cursed.
All right, 3, 2x plus 1 equals 4 to the x minus 3. So, when you have one base with one exponent, we're going to actually go, hey, we can convert that to a log. We're just not doing that right now. We're going through all the log base 10, because if at least you go to solve something and everything else falls out of your head and it's an exponent solving, at least maybe you might be like, log base 10 both sides, you know? Like if every other method falls out of your head, you might be like, I can just log base 10. Common base, I can log base 10. If I can convert it to a log, I can still log base 10 it. If it's really hard, I have to log base 10 it. So no matter what, log base 10 both sides actually works for every solving exponential. It might just not be your fastest way, right? Like the one where I said, I gave you a base to an exponent times a base to an exponent over a base equals a base to an exponent times a base to an exponent over a base. That you could log base 10. You'd want to quit because it's awful, and you should realize, hey, I could common base. Yeah. So let's try this one out. We're going to log base 10. I always say for the first one, I at least write the base so I don't drop that 3 down. 2x plus 1 equals log base 10 of 4 to the x minus 3. Take your exponent, drop it in front in brackets. You remember to distribute. And you can only drop it in front of a log because that's the power rule of log, and it's on your formula sheet, right? Remember, on your formula sheet here, it states that if I have log b m n, I can take the n and drop it in front and write as n log b of m, right? I can drop it only with a log. Has to have the word log there. So we have 2x plus 1 log base 10 of 3 equals x minus 3 log base 10 of 4. What's our next step then? Distribute. And you can drop the log base, the 10 off if you want. If you promise you won't drop that 3 in the spot. So we get 2x log base, or log of 3 plus 1 log of 3 equals x log 4 minus 3 log 4. What do you suppose we're going to do here? And if you don't know what to do next, pretend the logs are just numbers, okay? So this would be like 3x plus 7 equals 4x minus 8, right? Just pretend the logs of that, yeah? Make it so the x's are on one side. If you had 3x and 8x, one on one side, one on the other, you would move them to one side, correct? That's all we're doing. Pretend the logs are just numbers if you get stuck on like the steps. Because if I gave you like, off to the side, if I gave you 2x plus 1 equals 1x minus 3, you'd say, oh, I need to move my x's together, right? That's what you would tell me. It's the same thing. They just look weird. So I'm going to subtract my x log 4. And I get 1x, ooh, that's a lie. I get 2x log 3 minus x, or 1x log 4. Why can't I put them together? Yeah, one's like, well, they don't seem log. Yeah, like one is a log, yeah. One's a log 3 and one's a log 4, right? Like this is like an xy and this is like an xz. I can't put them together, they're not common. And then here I'm going to subtract log 3 to this side. So I get negative 3 log of 4 minus log of 3. What can I do next? Pardon? Yeah, take out a common factor of x. The reason why we get the x's to one side is so that we can take an x out of both terms. Here's the term, here's the term. There's 2 times x times log 3, 1 times x times log 4. I can take an x out because they're all multiplied. So I take out an x, and I'm left with 2 log of 3 minus log 4 equals negative 3 log 4 minus log 3. And the reason why I wanted to teach you this earlier is once we go through all of our other rules, we'll be able to simplify this part way better. But when I try and make people go through all the steps and then do a big old simplify at the end, it's almost overwhelming. So we're going to do this first, and then when we hit it up next week and simplify it into exact values, you'll be like, oh, that's not too bad. So we're going to divide by this ugly thing. That's really looking ugly because it's wrecking my writing. So, can we check and see if we're right? Yes. Type this into your calculator. We're just doing a decimal for today. We're just doing a decimal for today, typing it in. Make sure if you have the TI-83 kind that you put the numerator in brackets, then the denominator in brackets. Then I would like you to type the original into your calculator and try and find the intersection. And honestly, to be honest, we shouldn't have an equal sign here. What should we possibly have? Does anyone know? Yeah, 2 squiggles, because it means approximately. So you should actually have like almost like a little wave, like this. Because that means you approximated it. But if you put equal signs, you're right. It is still the solution. If they say to the nearest 10th or 100th, you can put an equal sign because you made it equal to the nearest hundredths, right? I'm just putting an approximation because I didn't give you a rounding rule. But if you give a rounding rule, you should be able to put an equal sign and box it because they say, what is it to the nearest 10th? Well, it is equal to this, to the nearest 10th, or to the nearest hundredths, right? You put equal signs. I'm just putting approximation signs because I'm rounding it fully knowing that I don't have a rounding rule on here. Okay? Now, everyone should type it into their calculators. I know that my answer is negative 6.48, right? So hopefully on my calculator it's negative 6.48. So when people are like, I don't even know where to look for it. Look close to negative 6.48. Hopefully you're right, okay? So when we type it in, what was the original again? I can't see it.
3 to the power of 2x plus 1.
Remember, if you don't have the one going up, you have to have your exponent in brackets. And then 4 to the...
X minus 3.
So I'm hoping the intersection is near negative 6 point something. People are like, I don't know where it is. I can't even... Well, I'm going to go near negative 6. Second tree is 5. And it should be near there unless I'm completely out to lunch with my answer. Do you actually have to go to negative 6 point something? No. I'm proving it. Ah! There it is. Like you should have found the answer first, correct? So you should know where you should kind of maybe put the little blinking dot close to, right? Yes? Agree? People are like, I just don't even know. I start over here. And I'm like, but you know the answers. Go near it. Yeah.
Do you need to make the cursor go near it when you do this?
Well, if you're way too far over, it won't jump onto the other graph, and then it'll just keep erroring. So then you have to move on, jump onto the other graph yourself, and then get it. So I just bypass that completely and just go near the answer, and then I don't ever have the problem where it won't bounce off one onto the other curve. They're too far apart. But you could just error it over this. But people will sit there and enter really viciously and like, it doesn't work, and they call me over and they're really mad. I would just go near it. Blinking dot. Here's the answer. Okay, one last big kahuna. Ready? What if I do this? It's going to use a new log law. Star the crap out of this one. highlight it, box it. It has done the worst out of every single log question in the entirety of man. I don't know, there's probably other ones that are worse. But in my life, this I've experienced, this one's done the worst. So, I'm going to put a 4 just to throw you off. Just kidding, I'll put a D. Okay. Star it, highlight it, box it, know how to do it. Okay? So in the previous one, I said 3 to the 2x plus 1. So I'm going to go 2, 3 to the 2x plus 1 equals 4 to the x minus 3. It's very similar to the previous question. I know within about the first 5 seconds if people are getting this right or totally wrong. This is one of those that are easy to mark for the most part because people do something wrong immediately off the bat and get it wrong. What do you think they do that's wrong? Yeah.
They don't distribute the 2 into the 2x plus 1 when you bring it over in the log.
No, even before that. What do they do? Yeah. That would be something silly to do. Yeah.
Maybe only log the 3.
Yeah, just
Nope.
drop the 2 into the star.
This is good because none of you seem to be doing the really bad thing or you're keeping it quiet. Yeah. Go 2 times 3. Make it be a 6 to the 2x plus 1. You're like, I'd never do that. So man, more people do that than do it right. So people will go, they'll go 2 times 3 and they'll make it a 6, or they'll divide the 2 over and make that a 2.
What?
Okay. Now some people, you're like going, what? Some people in here are like, why can't we? And I'm not being rude at all because I would have been one of those people who've been like, well, yeah, that sounds perfectly fine to me. Why can't we? Honestly, I would have. I'm not being facetious and I'm not hurting anyone's feelings here. That happens all the time, and I swear to you, in high school, when they first would have done it, I would have went to go put it in or divide it over. So I would have been like, that sounds fair. But we have to understand why we can't so that you don't do that. Okay? Remembering our rules. 2 to the x times 2 to the 1 equals 2 to the what? X plus 1. Our rule is we can only put together bases when there's an exponent attached to it when the bases are the same. We agree? And currently, this is 2 to the 1. This is 3 to the 2x plus 1. Can I put them together? No. Could I actually, if I wanted to, move the 2 over to the 1 and put those together? I could in this case, because I could make this be 2 squared. That'd be 2 to the 1. I could put them together. But most often, you can't divide it over and they're actually the same base. If I made this a 5, you're done. You literally can't move it over. Okay? So the only reason why we cannot put these together is it's a 2 and a 3. We could divide the 2 over and put them together, but that's long. I don't know if that's any faster doing it that way. Okay? And it doesn't work all the time. So please, if there's a base with an exponent, the only way you can join the other base with an exponent is if they're the same base. If they are not, you cannot do that. Do you see that? You can't put the 2 in with the 3. Make sense? You can't divide the 2 over and just make that be a 2. We agree? Everyone's on the same boat? Okay. That's the biggest problem that happens. Okay? Okay. So I look at this and I say I can't make common base. So what do I do immediately? Log base 10 both sides. So if you get past the first step of not shoving them together, this is the second step where they make an error, and if you don't make an error in the second step, everyone gets it right. So I know after the second step if we're getting it right, unless someone like fully writes something wrong, like puts a 2 where a 3 was, and they just oopsie or something. So if you get the next step right, this whole thing will be done right. Like 99% of the time. So we go log base 10 of 2. And I do this to prove a point. I put a multiplication symbol in there. 2 times 3 to the 2x plus 1 equals log base 10 of 4 to the x minus 3. Now, some people want to drop the 2x plus 1 in front right now. Can I? The 2 doesn't have a 2x plus 1, does it? So I can't drop it in front. So I somehow need to separate these. So some people will say, oh, it's log base 10 of 2 times log base. No, it's not. You can't separate them by multiplication. over to the right on your formula sheet, it tells you what to do when you have multiplication. So if you're ever stuck and you're like, okay, I know I need to get these separated. I know I need to get this into 2 logs because I know I need to get that 2x plus 1 down. And the only way I can get it down is if it's log base 3 of 2x plus 1. Then I can drop it in front. I need to get it down. So what do I do with multiplication? How do I separate a multiplication? Well, my formula sheet tells me how. You should never, ever do it wrong. Because your formula sheet tells you how to separate multiplications. It says, okay, if I have log base b of m times n, it tells me that I can just write that as log base b of m plus log base b of n. I would like to draw your attention to the fact that the log has a 1 in front of it. If the log doesn't have a 1 in front of it, you can't use it. Yeah.
Why is it wrong to drop the 2x plus 1 right now?
Because this 2 doesn't have a 2x plus 1.
I don't see where that's
There's not.
necessary from the formula sheet.
This one doesn't have 2 numbers in it. It doesn't have, this would be log base b of cn to the n. There's no c in front of this n. You see this one has a 2 times 3 to the 2x plus 1. There's 2 things multiplied in there. This has an m. This doesn't have 2 things multiplied. This would be like having 2 things in here. This doesn't have 2 things. This is a 2 times the 3 to the 2x plus 1. If you illegally put these together as a 6 to the 2x plus 1, then you could drop the 2x plus 1 in front. You'd be wrong because 2 times 3 to the 2x plus 1 is not 6. There's 2 things happening here. There's a multiplication. That one doesn't have a multiplication. So you have to deal with the multiplication first. And how do I deal with the multiplication? I separate them by addition. So I'm going to get log base 10 of 2 plus log base 10 of 3 to the 2x plus 1 equals log base 10 of 4 to the x minus 3. If I can get people to this step, they'll often do the whole thing right. What can I do with the log base 10 of 2? Answer is nothing. Keep it. Then what's my next step here? Drop it in front. So you just have an extra log for the ride on this one, that's all. And then drop this in front. So this is log base 10 of 2 plus 2x plus 1 log base 10 of 3 equals x minus 3 log base 10 of 4. And so then I get log of 2. I can drop the base off if I want to. Plus 2x log 3 plus 1 log 3 equals x log 4 minus 3 log 4. What's my next step always after expanding? Yeah. Move the x's to one side, number to the other. Fastest way to do that is to move this x to that side, so I'm going to subtract 2x log 3. And then I'm going to add 3 log 4 over. So everything with just a log gets together, and everything with an x gets together. So I get log 2 plus log 3 plus 3 log 4 equals x log 4 minus 2x log 3. What do I do next? I got the x's together for a reason. You always have to think that. Why did you get them together for a reason? So that you can GCF out an x, right? get x log 4 minus 2 log 3. This side stays the same. So if I say to the nearest hundredth, I can use the equal sign. So weird. In period 2, it picks up, and I can write like a normal human. Yeah.
Can we make 3 log 4, 6 log 2, and then combine it and have 7 log 2?
3 log 4. Be 6 log 2. Sure.
Maybe less terms.
Yep. Honestly, we're going to put them together. I'm literally just making you find an answer right now, because this is a whole bunch of steps. But then on Tuesday, we go through log laws, where we're going to go through the power rule, the quotient rule, the chain, and the multiplication rule, which we did, the product rule. We've already done them. We've looked at them, which is nice. And then we're going to go through them. And then we're going to come back and simplify these.
Oh,
So they're going to be written out as a log-based something of something. That's it. So we're just practicing the steps now. And then we're going to practice simplifying after. Okay, so your questions for this are, I'm going to put one on the board, you're going to do the answer. I'm going to put one on the board, you're going to do the answer. And then we're going to walk off having our homework done. Sound like fun? Have a nice long weekend to study. If we so choose. If we so choose. All right. I think I posted the chapter 5 and 6 podcast review already. Did I think so. I think I posted them all together last time. I think I did. I think it's on there already. It's a podcast review for chapter 5 and chapter 6 if you want to look at them. Yeah.
all the tests on Tuesday, right?
Yes. So Monday we're doing review, Tuesday is test. I would not just bank on Mrs. Lepp's review on Monday to be all of your studying techniques. That is 80 minutes. That is, I'm not touching on everything. I will try, but I will not be successful. Okay? So, here's a question for you to try.
How do you try to redefine language?
We're going to call it E because it just doesn't matter. You're practicing. All right. And these would say solve, right? These all say solve at the very top.
Yeah.
Try that one. Try those two out, and then I'm going to give you one with the number in front.
graph is just error.
Okay.
And then you try to.
Oh, okay. I was just wondering.
So for this one, we could take the t out. We're left with log 8 minus log 3 equals negative log 3. Even if you move it to the other side, even if you pick the other side to move the t's to and the logs to, when you divide them out, you will get the same answer. What do we get for this one?
Negatives, this is what
T equals negative 3.24. All right. B, what should we have gotten? Did anyone do it? You guys do B yet?
Yeah.
What did you get?
81.3.
You should get that for B. Due to time crunching. C, try this one. Ah! Just wait this board out for 8 years. Ah! Patience is a virtue I don't have right now. Why is it doing? Like it zones my body into it. Like I'm 20 feet away and
20 feet.
20 feet easily. Completely no, 20 feet is like this far. Totally accurate. Okay, solve this one.
Man, it depends on what scale it is.
Yeah, I have a scale of 1 centimeter to 1 foot.
So it seems like
So it's fine. Okay, solve this one. Okay. So we have to log base 10 both sides. And I always put the multiplication symbol in there to remind me that I need to separate two multiplication dealios. So I separate multiplication by addition, so I get log of 4 plus log. If you can get to this step, most people can finish this correctly. Distribute, so I get log 4. This drops in front. Remember, you're being recorded. 2x minus 3 log 9. Etch a sketch writing is just so awesome. Log 4 plus x log 7 plus 2 log 7 equals 2x log 9 minus 3 log 9. I'm going to subtract the x log 7. You could subtract the other one, but then you have to subtract 2. And so I get log 4 plus 2 log 7 plus 3 log 9 equals 2x log 9 minus log 7. Ooh, after I write it, after. Take out your x. That's why you got them together. 5, guys. What'd you guys get for an answer?
4.85.
4.85? So you have the weekend to study, but no homework, so there's no exponentials and logs on your brain. Monday we review, Tuesday is the test on trig chapter 5 and chapter 6. And then Wednesday we'll start with the daily quiz on this and see what you remember on all the exponential stuff we've done.